point-slope form of linear equations is another form of a linear function. It's still in the linear family, and it just has a little bit different shape to it than y equals mx plus b, and so it's another one of the linear forms. This one's specifically good if you're given a point and a slope. It's very clear in terms of what it needs. It needs a point and a slope. If you only have 2 points, then you can write kind of however you need to do based on how you're going to build it. We're just going to show another method of how to write a linear equation using this form. The form's a little bit different. You'll see some things that you recognize, and I'll try to use some of the same colors that you're used to. It's y minus y1 equals m times x minus x1. So some things in there that you'll see as familiar. You'll see m for sure, and that's slope still. I'll just go ahead and label our parts. Slope. You will see x and y, and I'm going to see if I can get a different color here just a little bit. X and y are variables that have to stay. They have the be there. The only way we make a line is those variables have to be in the equation. Otherwise, it's just an identity, and that's not going to help us out in terms of trying to graph or trying to look at something over the change in x and change in y, domain and range type thing. So that's x and y. Now, this x1 and y1, those are familiar, right? We feel like if we said P1 is x1, y1, right? So we kind of feel like this exists before. Yeah, that's the point. And so we have a point here that comes from P1. That's P1. So kind of as we look at the form, it's real simple, especially if you're given these things. It's going to feel incomplete. It's going to feel like they're just there, and you're supposed to do more with it. But if it is asking for point-slope form, this is what we're looking for. We're looking for a slope and a point, and that's it. So let's kind of try one and see what happens. Okay, so you're given the point -4, 7, and the slope m is 5/4, and so we need to go through and just start identifying kind of what we're dealing with. So this is P1 here. Bring that up just a little bit, and that's, well, I won't use that. I'll use black. That's P1, and then I have my M, and then I can start kind of looking at, there's my Y, and there's my X. And so I'm just going to start. I'm going to go, okay, this is the variable. I'm going to come back here and look at Y minus 7 equals M, which is 5/4. And we want to keep that as a fraction, times X minus, actually, the original equation says it would be minus up here. It says it would be minus, but we notice that this -4 is here, so we're actually going to turn this into a +4 and end it. That is point-slope form based on this information. So this is what we're looking for. It does feel like this, that's all we got to do. We just got to plug stuff in. Yeah, for the most part, this is what we're going to do. We're going to kind of plug it in, let it sit there, and then maybe build something else with it afterwards. So I'm going to try another one. I'm going to write it down, see if you can plug it in correctly. So pause the video once you get the information, and then see if it matches what I did. Okay, so your problem is going to be m is -7, slope's -7, and it goes through the point for -17. So I want you to pause the video, and I want you to try to see if you can figure out the best way to write this in point-slope form. Okay, hopefully you did get a chance. Make sure you work it out first, and let's take a look. So I'm not going to use quite as many colors, just to be a little bit quicker, but you will see that I'm going to say, okay, y is my variable y, and then I also recognize that I have this minus 17. And so because it's minus 17, this actually turns into a plus 17. It feels backwards, but that's kind of just how we know it's what it is. It's going to be negative. Is equal to my m, which is negative 7, times x, and that's my variable x again. And then this time it's going to be minus 4. It's kind of the opposite of what you see. And that's it. So hopefully that's what you got. Y plus 17 is equal to negative 7 times x minus 4. And so that's point slope form. It's pretty straightforward. You're looking at it from just a plug and chug kind of idea. Let's try one more, and then we can talk about a little bit of kind of where this can build to. So the last problem I want you to try on your own is m is 2/9, and it goes through, you'll hear that word a lot, through, kind of through the point 9, 1. Alright, so pause the video, give it a shot, plug in m and your x and y into point slope form, see if you can do it on your own, and then come back and check, and we'll see how you did. Okay, hope you got a chance to do that. Make sure you do it, get some good practice in there. I'm going to look at this and see, okay, first thing I recognize, got to put y, that's how it starts. Now this time they're both going to be minus because it's both of the parts of my points are positive. So that's my y value. So I'm going to have y minus 1 is equal to m, which we said is 2/9. So 2/9 times x, which is my variable, and then times my x value, minus 9. So there you go. Hopefully you got that one right as well. Now let's look at kind of how this works with the form that you know best. So if this question went on to kind of ask you, hey, what's b? So if I asked you to find b, it's saying, hey, what is the y-intercept? And you're thinking, man, now I got to plug 9 and 1 in, and I got to go back and do 1 is equal to 2/9 times 9 plus b. Yeah, you could do that. There's nothing wrong with that. That could work great. But kind of watch how point slope works here. Point slope is going to work itself into y equals mx plus b. And so remember, this is the key point here, this whole thing right now, that whole thing is point slope form. Okay, so that is point slope. So if it's asking for point slope, it needs to look like this. No distributing, nothing like that yet. But if it's asking you to find b, we can start kind of working through this. And so I'm going to rewrite it here real quick. Y minus 1 is equal to 2/9 times x minus 9. Okay. Now comes the fun part. I'm going to see this as an opportunity to solve for y. The reason I know I'm going to solve for y is because slope-intercept form is y equals mx plus b. And so I recognize that y is by itself. And so what you're really doing here back in point slope form is you're doing a literal equation for y. You're just going to move everything else. It might not completely solve, but we're going to move everything else to that right side. And we just need to clean some stuff up. So first thing I'm going to do is I'm going to distribute 2/9. So we're distributing because we're going into to find b and into y equals mx plus b form. So I'm going to end up with y minus 1 is equal to 2/9 x. Now, we have 2 times negative 9 divided by 9. So 2 times negative 9 is negative 18 over 9. So negative 18 over 9 is actually negative 2. And so that's what we'll write here. Okay, so I'm almost there right now, but I got a little bit more left to do. And so as I'm kind of writing this out, I still see that this y minus 1 is still there. And so I'm going to come in and I'm going to add 1 to get y by itself, and that's going to cancel. So I'm going to add 1 there as well. So when I write this out, finally, I'm going to get this. Y is by itself, which is what I wanted, equals 2/9 x. Negative 2 plus 1 is negative 1. Plus b. And so what is b? Since it said to find b, I know now that my b is equal to negative 1. Just because I simply went from point-slope form down to slope-intercept form, and it got me my answer. So they work really well together. Getting from point-slope form into slope-intercept form is great and actually has some purpose for us. Slope-intercept form, the one we're used to, y equals mx plus b, is great for graphing. It's great for putting it on a grid, graphing something out, seeing kind of where that initial value is, and really building off of that. Point slope form is a really good snapshot during some time frame or somewhere in the problem, in the scenario, in the situation, in the model, and you want to see how it acts around that point. That's why we call it point slope. And so we're not really concerned as much with the starting value as we are with a specific point in space. They both have their purpose. They both have a function, but remember, they are both parts of the linear equation. They are the same thing. It's just a different description of the same linear picture, if that makes sense. Last one I want to do, we're going to run all the way through an entire problem, kind of put it all together, and I'm going to use point slope form. And so again, for your work, you're going to try point slope form, but it's really going to come down to whatever method you like the best and whatever's going to work best for you. So here's going to be our problem that I'm going to give you. And again, I want you to pause it when you get it and then try to work it out on your own and then come back and check to see if you got it right. And so I want to look at the line that exists between these 2 points. And so we always said that there always is 2 points there. So I guess there's always a line between 2 points. Write the equation between the 2 points and find b. All right, so again, pause video. You have 2 points. You're going to need to find slope, and then you need to plug it into point slope or slope intercept. Try point slope since that's what we're working on, and then come back and check and see if you got it right. Okay? Good. Hopefully you're able to do that. Let's take a look at how this works. We need to find slope first. And so I recognize that this is x1, this is x2, this is y1, this is y2. Now, if you flipped those, that's not that big a deal. As long as these two are the same and these two are the same, we're good. So if you said that 3, 7 is actually x2 and y2 and negative 2, negative 13 was x1 and y1, you're going to end up with the same answer. Just kind of work it through. So see how this works. So y2 is negative 13 minus 7 over negative 2 minus 3. And so I'm going to work into the negative here. So I get negative 13 minus an additional 7 is negative 20. Over negative 2 minus 3, that's going to be negative 5. And so I get that double negative there. I now figured out that my slope is equal to 4. All right, not bad. So now that I have my slope and I have 2 points that I can pick from, I'm not going to go into slope intercept. I'm going to go into point slope because I have a point and I have a slope. So I'm just going to do it. So it does not matter which one you pick. They're both going to be the same. They both communicate the same picture. I'm going to use 3, 7 because it doesn't have any negative numbers. Doesn't matter right now. It's good. So I'm going to do y minus 7 is equal to my slope, 4, times x, the variable, minus 3 from my point. So that's point slope form. So that, if that's what it was asking me to do, I'm done. Great job. So I've written the equation, which is fantastic. Now I need to find the b. Okay, so to find b, that's what I'm looking for. I'm looking for b. To find b, I'm just going to go through and solve this equation for y, because I know that y equals mx plus b will tell me what b is. So I'm just going to go ahead and go through it. First thing I do to solve this point slope form is distribute 4 into the xn negative 3, and I'll get y minus 7 is equal to 4x minus 12. All right, so again, this x or this y isn't quite by itself, and so I'm going to come in and I'm going to add 7. And so once I add 7, I'm going to get y equals 4x and then negative 12 plus 7, so I'm working kind of my way out of the hole a little bit, is going to be minus 5. And so I'm looking for b, and now I have found b. So here's my equation. And here is my b. So hopefully this made a little bit more sense. Point slope form, this piece right here, is just another type of linear equation. It's not different, it's just a different description of the same picture, of the same scenario. The linear equation is still the same. It's going to work into slope-intercept if you work it out. If it's just asking for point slope, stop right there and be good with it. Hopefully this gives you kind of another tool in your kit, another option to how you want to solve things. Good luck on your work, and let me know if you have any questions.